Today I'm going to explain you the very basic video of refraction and how does it take place. When a light ray or any wave, it can be entering from one transparent medium to another transparent medium. In other waves, we used to just say one medium to another. It's like the light refraction, so it's like one transparent medium to another transparent medium. This one has the refractive index of N1 and N2. You don't still know refractive index if you are really new to this one, but you are pretty sure you have done these things. So this is the direction how the wave was about to travel. So the wave may bend away from the normal of this line, the normal line, or towards the normal. So away from the normal take place in the rare medium. Comparatively, if it's a denser medium, so the wave may bend towards the normal. This is the first thing you have to know. Okay, after that, so the wave can be just explained like in terms of what? Snell law. Snell law number one is the ratio of angle of sine ratio of angle of incident and the angle of this refraction is constant for certain medium. Right. So you can represent that in terms of n equals to sine I over sine r. So you can also write like this one in another way, but c over v. C is the speed of light. This one is speed of the wave. Have a really good look at here. So down here, the n is sine I, sine value of the angle of incident, the sine value of the angle of refraction. So you can just write the equation in some other form, like n1 sine I is equals to n2 sine of r, one of the way. And in terms of the speed, you can write it like this way. But n1 v1 equals to n2 v2 as well. So how to write this v thingy? V is equals to f lambda. F cannot be changed in the medium. It's a constant. So n1 f lambda 1 equals to n2 f lambda 2. F and F cancel. So now you will get the results like N1 lambda 1 equals to N2 lambda 2. Very essential equation to answer for MCQs mostly, right? You'd better memorize this somehow. No need to just memorize like by heart. Just remember, really easy. Getting the theory, is the basic understanding, you can understand. The next layer is the incident ray, refracted ray, and the angle of normal drawn to the common interface are in the same plane. Now see, all three line in the same plane. If one is just away from that, all three different planes. So this is the second law, Snell's second law. Now let me explain you that total internal refraction. Really simple one. So according to the total internal refraction, it's always move from the dense medium to rare medium. Right. So have a look at here. Just bend away. So the light ray bends away from here. The light ray bends even more away to maintain the same ratio. Now it's very closer to the normal. Now in one specific angle, it is just moving along the common interface. At that time, the refraction angle is 90 degree. R equals to 90 degree. Okay. At this time, it's really essential one to know. Critical means the critical condition. He's in a critical condition, we used to say. But what is critical? Critical means it can be anything. If the angle increased by a very small fraction, this is what happens. The wave may total internally reflect back. This is the angle of I3, little bigger than C. I1 is, I2 is greater than of I1, C is greater than of I2. Now I3 is even greater than of C. Now the reflected angle is also I3. Just behave like a mirror reflection. Right. Let's see the mathematics here. Mathematics is really simple. What is this? You can apply N1 sine I equals to N2 sine R. What is this one? N sine C equals to sine I is 1, sine 90. Sine 90 is 1 again. N equals to 1 over sine C is the very simple derivation. Very simple derivation. Okay, now see this most frequently gettable question. One is, when you keep certain source of light, you may see only a patch of light around here. So this is the 3D model. So all the other light rays went back. So we can only see what? Only this surface. Only this brighter surface, all the other light rays are not. In practically, it's very hard to get this thing. But because our surface is exactly like a linear line. But theoretically, you can have it like this. If you get to ask the radius of this cone, it's like a cone. So what is it? The height is h and the radius is here r. So what is the ratio? This angle is theta. This is what the critical angle. So when you just get this one, it's the alternate angle here. When you consider this angle here, r, h, and theta c. So what is it? R over h equals to tan c. So r equals to h tan c. You can easily get this result and find out the radius. This is somewhat may come in a question. The next one is really important to know that the what is it? Fiber optics. In a fiber optics, a wave light ray enter to this one, and to critically all the time the angle is greater than critical angle. Reflect back, reflect back, reflect back, and if you enter a certain signal from here, some pulse, so it will just travel to the detector, and it may speed up light faster and noise free. It's really essential. And the next one is like the refraction occur in a prisms. In refraction occur in a prism means like, see, the angle of incident is now greater than the critical angle. It will just get bent like here. The angle is like normally maintained here like the 90 degree, normally 45, and this one is like 45. So 45 is normally the critical angle is like 41, 43 range for glass. 45 is greater. So this one is again 45. This one makes a 90-degree angle. Again, the same thing happens. And exactly gives a phase difference of 180 degree and make a U-turn bend. Very simple thing that you have to remember in terms of critical angle. I have uploaded many questions discussion under this one. You can watch those videos and get to know in the class recordings. These ones are specially made videos to revise the theory parts only. So if you learn something, please subscribe to my channel. Thank you very much.